In this section, we'll be looking at ways to show that triangles are congruent. These two things are called the side, 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 and side angle side theorem. The reason we'll be doing this is because in the last section we had to match all 6 parts. This is kind of overkill. There's a lot of writing to do for each problem. And so we're going to show that with triangles, it's actually enough to know fewer things to prove that they are congruent. The first one is called the side, side, side postulate. And what this is saying is if we know that the 3 sides are congruent, there's only one way that we can put this together to get a triangle. So looking at this example here, if I have 3 set lengths for the sides of my triangle and I try to make a triangle out of them, well, when I bring those 2 sides together, if the other ends are already connected, there's really only one place that they can connect. Actually, there's 2 places we can see down below, but that actually gives us a congruent triangle to this. So no matter what I do, I'm going to get some set angles based on where these things are able to intersect, where these side lengths are able to come together. Even if I change my side lengths, all that changes is where they're going to meet. And so with a new set of values, that's going to give me a different triangle. So this is the side, side, side postulate. Notice they abbreviate it with SSS. As we go around, we have side, side, and side. So if we're going to use the side, side, side in a proof, it might look like this, where they give us a couple pairs. Now, notice they did not give us this part here, but we can mark that because it's shared. So using the reflexive property, you notice that Ln is congruent to itself. Now, since that's in both of those triangles, we can now say that triangle L to M to N is congruent to our other triangle. Okay, so L corresponded to N in our other triangle. P corresponds with M, and then N corresponds with L. We did that by side, side, side. The next one is the side angle side postulate. Now the order of the name is important. It says that we have a side, then the angle, and the side. We'll also often say the included angle, but we can think about that as we're going around in that order. A side connected to an angle connected to a side will give us side angle side. Notice it's the same in both of these triangles, so they are congruent. Now to see a picture of that might look like this, where I have a certain angle that I want and I have 2 sizes of sides that I want. Now, however I do this, if I'm putting those two, if I'm keeping this as the included angle, there's only one way that I can make this red side go over and meet where that angle is, which means there's only one way that I can draw my third side here to make a triangle. And so having a side and an angle and a side is going to set a specific triangle that I have, and so every triangle with the same side, included angle, and side will be congruent. In this example here, they ask us what other information do we need. So if we look at what we have a couple of sides. Notice we also have the reflexive property here. So if we're going to try to use side angle side here, what we need is the included angle. On this triangle over here, the included angle would be this angle, and down on the bottom triangle, the included angle would be over here at D. And so what we need to show is that angle EFD is congruent to angle GDF. If we can show that, then we would know that these triangles are congruent by side angle side. In this last example, we're supposed to justify whether or not these triangles are congruent in each pair. So if I look here, I have a side, the included angle, and the side, so we can say that these are congruent by side angle side. If we look at these two, though, notice that this side over here does not give us the included angle. That would need to be this angle up here. So these are not congruent because we do not have the included angle. The next one is very clearly, we have 3 pairs of congruent sides, so side, side, side. And the last one, notice we also have 3 pairs of congruent sides, so we could say side, side, side. But also notice that there's something else happening in this one. If we look at this right here, we've got a vertical angle. And with vertical angles, we know that those 2 sides are also congruent. And so we could use the side with 2, the side with 1, and that included angle there. We could also use side angle side on this one.